Hello everyone, this is our first video from home. How exciting. That said, I still don't have an internet connection, which is not exciting. We're doing permutations now, and that's calming. And permutations are just basically like an extension of factorial, which is what we were doing now. And so if we look at, a really simple one that we've done before, how many ways can we organise the numbers 3, 7, 1, 5, and 1, 2, and 4? Now we see that there are 5 numbers. And so because there are 5 numbers, it's just going to be 5 spaces. There's 5 options for the first, 4, 3, 2, 1, or as we know it, 5 factorial. Sorry for the blip there. So let's now take it to the next level. What about if 50 cards in a deck and 3 are chosen at random without replacement? How many different ways can they be chosen? And so hopefully by now we can do this one. We know that for this one, there's only 3 options. There's only 3 cards, should I say, but there are 50 options. There's 50 cards for the first one, 49 cards for the second, and 48 cards for the third. Now I know that comes out to, there is 117,600 different possibilities, but there's another way that we can write this. Rather than writing it this way, which is the way that I do for my junior classes, we can introduce P. And so another way we can write this would be 50P3. And really, 3 is referring to the number that we're choosing, and 50 is the total number in the deck. And so we can basically rewrite this. Rewrite 50P3 as factorial 50 divided by 50 minus 3 factorial. And so really that comes out to being factorial 50 minus 47 factorial. And if you think 47 times 46 times 45 and so forth, that cancels out by dividing it by a factorial 47. That cancels out all the remaining parts. And so it's really, really handy for us in this case. Oh, sorry, didn't realise I was recording. And so, what's the rule? The rule is NPR, or it's just basically the number of ways an ordered selection of R objects can be taken from a total of N objects. In other words, there's a total of 50 objects here. We want to take R of them away. So 50PR is just saying there's 50 objects, we're taking 3 out. And so let's look at a more practical example here. There are 10 digits, 0 to 9. Find the number of arrangements that can be formed from the 10 digits. Okay, and so I forgot to add part of the question. Find the number of arrangements of 3 digits. Sorry, let's add that now. Can't really see that, can you? Of 3 digits that can be formed from the 10 digits. So in other words, back in the day, we would have just said 3 times that, and we would have said 10 times 9 times 8 because there's a total of 10 and so forth and so on. But we can, we're a bit more mature mathematically now. We can write that as 10p, 10p3. Right? And now let's have a look on our calculator. Because you don't realise it, but just above, you can't read it, you might not be able to see it with the resolution of this. Just above your times, if you press the shift button, there's a P button. And we can actually write 10 shift times, and you'll see a P turn up, 3, boom. There are 720 ways. Now, if we look at the next question, well then how many ways how many digits over 700 can be formed? Pause it here, have a go. This is a bit tougher because now what we're going to do is we're going to fuse what we did in the past and our fancy new permutation notation. Pause, good. Now, welcome back. In this case here, how many digits over 700 can be formed? If we look at it, like this is nice and easy. We can do this without permutation, doing a permutation on our calculator. There's only 3 options over from 7, 8 or 9 to choose from. So here, and obviously there's 9 left and there's 8 left after that. Now we could also write that as 3 if we want to, from what we've learnt, 9p2. Fancy? Now we're getting hectic because now we're saying, well, how many ways are there of organising the letters in the word Ulladulla? Now before we would have gone, oh yeah, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in Ulladulla. Sweet. Right? And so we would have just said, there are factorial 9. And in that case, we're partially right. But what we haven't taken into account is what's the difference between this L and that L? In other words, we're looking at repeats. When you have repeats of things, it doesn't matter which L is first. It's not going to be a new way of organising it if the first L is before the second L and vice versa. I hope you followed me on that. In other words, when we have repeats, we need to cancel out all the repeats and say, well, how many different ways can things be repeated? Because in here, we've got 9 possible, or factorial 9 factorial ways of organising this. But we've also got 1, 2, 3, 4 L's. So how many different ways are those L's going to be able to be organised? 4 factorial ways can those L's be organised. So there's going to be 4 factorial ways of organising this 9 factorial, or should I say ways, in this 9 factorial, which make no difference whatsoever, which will look exactly the same. And the same here, we've got 2 A's. So the first A and the second A, they're no different from each other, and so we can divide by 2 factorial. And then in the same with the U's. Oops, 2 factorial. So we can do this in our calculator. Fancy 9 factorial divided by 4 factorial times 2 factorial times 2 factorial. Boom. 3780. Ninja. Now let's look at the next one. This one's even a little bit more hectic. How many ways, if there's a circular table with 6 seats, how many ways can the people seated be organised? 1, 2, 3, 4, 5, 6. All right, beautiful. And so originally, if they're in order, it would be 6 factorial. But there's no order. What says that's the first one, or that's the first one, or that's the first one, or that's the first one? So in this case, the first person, 1, 2, 3, 4, 5, 6, we can still explain it this way. The first person can sit anywhere. So it doesn't really matter. Whereas the remaining people sit relative to that person. And so in this case, how many different ways can they be sorted? 5 factorial ways. And then again, this is much the same as the repeat, but in the process, but a different concept. If 3 people want to sit together, what's the probability they will sit together at this table? I just added that last bit because I didn't write it down. And so then we need to say, well, how many different ways can these 3 people sit together? Because if these 3 people want to sit together, they can be organised in different ways. And so they are going to be able to be organised in 3 factorial ways. And so in this case, the probability is going to be 3 factorial over the total possibility of ways that anybody can be seated at the table, 5 factorial. Now, this is conceptually quite difficult for some people, and so it's going to be a practice game. But I believe you can fly. So from me and from Carmen. Come on. we say goodbye.